here. My name is Jeff Morris. I run product marketing, and I've been with Couchbase for about 1 year and 6 months. Um, but and I've been in the NoSQL database space for probably 10 years, 15 years, something like that, quite a long time. What I want to talk to you today about is the migrating from relational database technology to NoSQL. But you actually will enjoy the one of the first previews of that message and that story as it relates to what's coming out in Couchbase 7 in July. So I'm merging together both of those concepts for you, because with Couchbase 7, the capability is much stronger and much more powerful for our customer audience. With me today is Matthew Groves. He is a former developer advocate at Couchbase. He's been with the company for over 4 years, and he joined my team. And Matthew's been focusing on building utilities for how to migrate a Microsoft SQL Server database into Couchbase 7, and demonstrating exactly how you would go through that process, and talking about some of the decisions you make along the way and the key considerations there. And we'll have Matthew show a demonstration of this capability for you in a second. So to that end, what I want to end up establishing for you is one, why customers are going to need to migrate out of their relational systems, the pains that they are experiencing, and some of the qualification questions that you might go through to ask them about their pains. We'll introduce some of the new capabilities inside of Couchbase, specifically the schema mapping mechanisms that we call scopes and collections. It's a brand new dynamic data containerization set of features that sweeps across the entire Couchbase product line. Now, Juan Carlos, I'm going to assume that these partners all are reasonably familiar with Couchbase itself. Okay, very good. Okay, so then we'll talk about those core capabilities of Couchbase 7, why customers love Couchbase itself once they start using it, especially. Yes.
Sorry to interrupt you. All of them have a agreement in place, so they are a formal Couchbase partner in the region. Okay.
Right, and so they understand the multi-model capabilities and things like that. So those things I don't necessarily need to keep explaining to them. But what I will, and I'll touch on these, but those core capabilities of Couchbase, I'll review, but not go in depth on, because they already know this. What we're seeing right now is the pains that customers go through and reasons why they call Couchbase. And on the left-hand side of this slide, the pains, the pains section is oftentimes they experience, they have an existing application and they experience performance issues. And this is especially true when because customers have increased their usage online of these applications. So they're creating stress on those applications themselves. So performance issues is a reason why customers come to us, and we typically sell to them the caching capabilities and distributed capabilities for scaling an application either out to devices or out to mobile or across, in a distributed nature, perhaps data center to data center or country to country. Oftentimes, another pain point that they come to us is their cost of operations is increasing at a too rapid a rate, and systems are becoming too expensive. So Oracle is a very, very expensive product to be running, and traditionally increases their costs every year. And finally, the third pain point is they face innovation roadblocks. They are unable to change their old system and therefore they're not able to move forward with new requirements for their enterprise applications. So they may desire to change their application, to add mobility, to add new capabilities, new customer experience capabilities, and yet their old architectural designs prevent them from doing so. So some questions that we typically will ask of this, of our customers is, number one, are they discovering from the inflexibility standpoint, are they discovering that their application or their data model is adding requirements for change, but they are unable to satisfy those changes? Number two is, are scaling issues like user concurrency, the number of users that are accessing the system, or data volumes swamping their existing systems? That's a good question for those performance issues. Or are your applications behind your digital transformation goals, right? Are you not able to move your applications forward fast enough? And number four is, do your developers cringe or avoid schema changes or adding new features to your application because the degree of difficulty is very high? And five is the cost of making these changes too high for you and preventing you from doing anything? And six is managing or evolving a sprawling set of databases become very difficult to manage? So each of these questions are good for qualification of an opportunity to understand what particular pains those customers are having. Now, we've been breaking down a lot of the core requirements for modern applications as we see them today. And what you'll notice, and this is true of many, many Couchbase applications, they include combinations of users or people or employees. And the goal of the application is to deliver a personalized experience on any device, regardless of where those users happen to be. Now, this is true in travel-based applications such as what I'm showing here, but it's also true of logistics applications like DHL or United Parcel Service performing package tracking. It's true of retail applications where curbside delivery of the products that are available in the grocery store are also highly personalized. I'm noticing a couple of questions very quickly. Do you want to run through those, Juan Carlos?
Actually, it was me, Jeff.
Okay.
Yeah, I'm saying if anyone feels comfortable putting the questions in Spanish, we can translate them.
Excellent.
Thank
So
you.
the third and fourth requirements here are, we need to execute transactions dependably inside these applications. And transactionality is typically something that a relational database does very frequently, but NoSQL databases oftentimes pass the information to the relational systems to complete a transaction, such as a purchase. But the NoSQL systems don't often support transactions because they're compromised between building a massively scalable system and supporting core transactionality capabilities sometimes conflicts with each other. Now, Couchbase has solved this. So Couchbase supports distributed ACID transactions and has now incorporated that inside the NCL query language to make our transaction capability significantly stronger and more important in our story. And finally, we need to scale these applications globally, oftentimes in a mobile environment supported by 5G or supported by other distributed data kinds of capabilities. Now, my yellow boxes, my yellow requirements are more for the developer and the DevOps individuals. Their requirements on the back end are to make sure that the application can be deployed anywhere and suffer zero downtime. They want to simplify the complexity of their architectural stack so that they can develop applications more quickly. and they want to reduce that database sprawl. That's a common common capability or common reason why people would pick Couchbase, is because we support so many of those consolidated capabilities in a single database. And finally, they want to be able to preserve the development skills of the developers themselves. Most developers know SQL. Most developers understand schema and tables and how databases operate with a structured data model. And Couchbase 7 allows us to incorporate those capabilities into their applications as well. So typically with a relational database, when we're talking about moving out of something, is the challenges for relational databases are oftentimes in scaling or in replication or in availability. And the requirements for availability is increasing, as we just demonstrated. It's because users are global. Data, it needs to be distributed all the way out to users. It should be processed as close to the user as possible. And if this is a multi-data center kind of environment, it needs to be resilient under stressful situations like a data center failure. So our cross-data center replication is a mechanism that allows us to maintain very high degrees of availability, even in the face of these kind of failures. So we are starting to characterize Couchbase as a modern database for enterprise applications. And these applications do incorporate these core requirements. They need to run in a distributed manner. They need to support users globally. They need to provide a very high level of performance and usability with sub-millisecond response times, and always be available with a strong service level agreement. So what we often see traditionally is customers have used multiple databases to provide these kind of capabilities. They would deploy a NoSQL database for those interactions and make sure the interactions are happening quickly. They would deploy a relational database to support the transactions that need to occur to process an order or confirm shipment, things like that. And then ultimately, to understand customer behaviors, they would use a different system for Customer 360. So the user profile and preferences, so that if this user returns to me at a later date, I know about them and I can remember what their favorite color is, what their favorite set of products are, and use that to enhance the user experience for them. So what's really interesting now about Couchbase 7 being introduced is we feel very strongly that the relational versus NoSQL database debate, should I use transactionality or should I use flexibility and scale of NoSQL, that debate is over. You can choose Couchbase to support all of these capabilities at once. So we are characterizing ourselves as a modern database that fuses the transactional strengths of relational database technologies with the flexibility, performance, and scale of Couchbase, and typically, to reduce costs, to support running Couchbase in the cloud. So that with the strengths of relational, they get that trusted and familiar capabilities like a schema model from which to design and understand their data model. They get ACID transactions in the SQL language that they're using. They get SQL familiar constructs like joins, which most NoSQL databases do not support. They get user-defined functions. There's a new cost-based query optimizer. There's parallel index generation. So index builds inside of Couchbase will happen much, much more quickly than they did previously. So they get all of those core strengths of relational technology fused with the flexibility of Couchbase itself, with editable JSON capabilities, with multi-model data access support, so they don't have to pick multiple databases, they can pick one. They get the independent data processing services like data query indexing, the traditional capabilities of Couchbase, to which we've added a new backup service to improve that availability we mentioned a moment ago. And they get to choose the programming language in which they build the application itself. Couchbase will be will allow applications to be built, however the preferred language for that organization happens to be. And when you need to scale it, it continues to scale as Couchbase has traditionally, as you know. New capabilities inside of Couchbase 7 are data rebalances are significantly faster, about 4 times faster. Memory consumption and CPU consumption has been reduced, so we can do more work on a single node or on any given node than before. And as our data model and our granularity of how we use collections, that allows us to process data much more quickly. Collections and their global secondary indexes are portable very, very easily. So that's what makes replication faster. That's what makes rebalancing faster, those kind of things. So when I talk about multi-model support or multimodal support, these are the data access methods for how we get at data inside of Couchbase. We traditionally had characterized ourselves as a document database, and that is still true. We now support all of these relational concepts. So I am incorporating the relational capabilities that you are familiar with from Oracle or DB2 or SQL Server. We operate as a very fast key value store, running in memory and accessing data very, very quickly. We include full text search, so you don't need to go look for Elastic or Lucene or other technologies. And search is often a very, very handy, useful capability when you're doing geographic searches, right? How close is a coffee shop from my location? And finally, supporting real-time analytics built into the environment so that your application can become more and more intelligent the longer that it runs, being fed by this analytic capability. So overall, Couchbase, as we present Couchbase 7 coming up in July, what we'll talk about is we're delivering a simplified architecture for developers by adding this new data containment structure, scopes and collections. So it's a familiar structure that looks like database schema to that developer, and it maps easily to to your old database. Now, this is a sweeping feature that works with every single service inside of Couchbase, including security, including clustering, including the automatic sharding and replication. And it even allows us to build out better multi-tenant designs for independent software providers so that they can decide how much resource they apply to any given tenant. And they can balance their cost of operation concerns with their security concerns of data isolation on a tenant by tenant basis. Number 2 is we expand our workloads into transactional applications. And that's the area that is typically dominated by relational technologies like Oracle and IBM and Microsoft. So our distributed ACID transaction support is moved into the NCL query language. That's a very, very big deal. And it also continues to be supported inside the application software development kits. Inside of NCL, we've added user-defined functions. We've added the new index advisor function. We've added analytic and eventing capabilities as well to enhance that developer experience and that mapping to what a relational database does. And we'll continue to support 100% uptime goals, including auto scaling, which is a new feature of Couchbase Autonomous Operator, as well as the backup service I mentioned a moment ago. So this will all operate much more quickly. Collection level data access and data partitioning and indexing will make the overall Couchbase experience run faster and allow us to lower operational costs for the customer. Indexes are a very, very interesting area of focus in Couchbase 7. So index builds, instead of building one at a time sequentially, one after the other, now we will build all the indexes in parallel all at once. So the time it takes to build your indexes, whether you're building 100 indexes or 1,000 indexes or 10,000 indexes, which is your limit, it will only take as long as the biggest index to build. So a much, much faster operation of index construction. And because indexes are tied to collections instead of buckets, indexes are smaller, and therefore processing an index will be much, much faster. And we've seen that in our tests. So let's talk a little bit more about scopes and collections and what they look like. It's a brand new multi-level construction organization structure inside of Couchbase that allows us to really clearly map a relational structure into Couchbase much more easily. As you can see, a bucket looks like a database. A scope is kind of the equivalent of a schema, a collection of tables. Collections themselves are tables. Documents are the rows inside the tables. And the key value or arrays or subdocuments in a document are the data values inside a cell. So developers can organize their data in that familiar way and carry over their legacy systems into Couchbase very easily. Now, and Matthew can end up talking about this more appropriately than I can, but we recognize that the moving a relational model into a document model may not be the most efficient way to ultimately operate your application. But the benefit here is it is the easiest way to get your application into Couchbase. And then once it's inside of Couchbase, you can make modifications on the fly without suffering downtime of the application and make, and evolve your data model accordingly without interrupting your user services. So your users will continuously see better and better performance improvements and operational capabilities as you move that very relational data model into a document-friendly model that is designed for very high performance. So this is an example of what a relational schema on the left would look like with customers and orders, products and invoices, and how that translates into collections and JSON documents directly. So we have customer collection, we have an order collection, we have our invoice collections and product collections. So it maps very easily to the same thing. And then we can start to optimize how we might make these perform better in taking advantage of the JSON structures. So I put these slides in as a reminder of, we have been doing this movement of relational structures into documents for quite a long time. So with the goal of denormalizing data into a single document, and or using persisting normalized data, you get that flexibility now, and then you can add new structures to the document. You can add new values to the document very easily, and it all remains portable and it all remains accessible, but through all of the different data access services we provide. The big advantage here, of course, is we're allowing the application developer to control the data and control what the application does with the data without involving a database administrator, or without saying that the database needs to dictate what data is available to the application. We are inverting this process and allowing the application to drive the data structures itself. That's a big shift for many customers, and may indeed end up upsetting database administrators. But to us, we think that the application flexibility is far more important for the ongoing maintenance and operation of the database. I think I talked about our high availability capabilities here. So when comparing a relational system to Couchbase, one of our highlights is the replication capabilities across data centers, and that there's no single point of failure built into a Couchbase application. If a data center goes down, the application knows enough to repoint their application to a different data center, because that's built into the application itself. There's not a single point of failure, which would be that pointer to where the application should look for its data. We have that taken care of inside of Couchbase as our sort of shared nothing kind of design. The dynamic schema model, I think we've covered. These are again slides for your reference. And of course, the thing we start to really highlight is how easy NCL is. It's SQL++ to regular SQL. So relational database developers will feel very comfortable adopting Couchbase itself, because the query language is so like SQL. And we support joins. Again, this is a big feature versus most of the other NoSQL databases. MongoDB, Redis, DataStax, Cassandra, all of those do not support joins in their environment. Neither does DynamoDB, neither does Cosmos DB. So all of these, that join capability, that familiarity of, I know how to do this in SQL, therefore I should be able to do it in this new database. That stays in place with Couchbase, and that familiarity is one of the favorite reasons why customers like Couchbase after they started using us. So all of the core capabilities of Nickel, joins, transformations, filters, aggregation, sorting, etc. All of these that SQL has built in, so does Nickel. And we want to keep reminding people that that carryover of skill is a very, very important reason why customers like Couchbase. So when we talk about our services, right, this is an area where you all should be familiar. JSON flexibility is important because user profiles change very frequently, as well as product profiles change. Your pricing models perhaps need to change and be very dynamic. And Couchbase does a good job of allowing those capabilities to be modified as the application is running. And that's one of the big values of using JSON as our core format. The familiarity of Nickel, the high performance of the in-memory services for processing the data, the ability to support different data access methods like search and query and analytics all at the same time, and the ability to support streaming, change data capture, integrations to other services through the eventing service, all very, very powerful in the Couchbase model. We always have to highlight multidimensional scaling and the fact that this scales elastically now. And if you deploy Couchbase with Autonomous Operator 2.2, you will now enjoy auto scaling. You can set your settings in the YAML file of a Kubernetes definition, and your set a threshold for how much every server, its resources should be monitored. And if you hit a high threshold, like my server is running at 80% capacity, then that could be a trigger to go and rebalance the application and add a node. And then if the performance or the load on that machine drops to 20%, you can rebalance the application to eliminate that node and save money on not operating that particular server. So we now do support auto scaling both out and elastically back in using Autonomous Operator. All of our core deployment capabilities, as described here, I've touched on most of these: MDS, active clustering, enterprise security, XDCR, etc. And finally, we get into some of in the collections area, the role-based access control is now pushed down into collections from the bucket itself. And so you can assign at a very granular level the security of who has access to a particular collection, who has access to a particular scope of collections in terms of, and this is all can be done on roles as well as users. So the core new capabilities inside of Couchbase 7, if you need a big list of what is the summary, is the scopes and collections implementation touched every service: the query service, index, backup, full text, analytics, eventing. Pervasive scopes and collections are put into Couchbase throughout. But then there's also those core capabilities of performance improvements in the search capability as well as in indexing. The new backup service that we've added, right, with a user interface built on top, so you can schedule when backups happen. That's all brand new. And then the user-defined functions, or the roll-up function or the cube function, are brand new inside of analytics. So the database itself supports much more robust processing of the information now that it has in addition to its new structures. So my final piece here we'll get into is, back to the why migrating from relational to NoSQL is so important. It's the primary reason is because once customers start to use Couchbase, our chart on the right-hand side, what do customers value once they start to use us is NCL itself. Right? They like the fact that the familiarity of NCL, they know how to do things there because of their 20 years or 15 years worth of experience programming in SQL. That knowledge persists and can be used moving forward. They don't have to learn anything new, and their productivity really increases quite a bit because of that carryover. So as I mentioned, now NCL supports multi-document transactions inside the query language itself. So this makes transactionality much, much easier to implement throughout the application and moves Couchbase into competition for transactionality at against relational systems. One of the reasons why an organization would keep Oracle is because of transactionality and their trust in the durability of the data that gets that Oracle processes. But now Couchbase carries that same capability. So when would you use transactions is all over the place inside an application. It could be for shopping cart and purchase processing. It could be inventory updates. It could be confirmations of purchases or shipping sent to the customer. It could be updates to the billing system. It could be registration confirmations. It could be offer presentation. It could be adding bookmarks to a media stream. So all of these are areas where having transactions built into Couchbase in the database itself becomes very, very important and expands our ability to support these larger, more comprehensive kinds of applications. And so we do think that Couchbase is as dependable or better than a traditional relational database. With ACID transactions, with multi-document and multi-node guarantees that those transactions will succeed or be rolled back. It scales very linearly. We've been testing transactionality from a performance standpoint as well, and it's scaling well. There's always going to be a performance trade-off between running without transactionality built in, with those guardrails or not. But it does scale linearly as you add nodes. The core new enterprise security capabilities, where the granularity of role-based access controls becomes much finer with collections. Overall granularity inside of the database, because the data sets that you would be working on are at the collection level and not at the bucket level. So all of these services will end up performing better because the data sets they have to deal with are smaller. So that includes, the data collection service, query, everything will operate more quickly because, like I said, the data that the amount of data that they have to work on is smaller. The limits are, you still have 30 buckets as a limit in Couchbase, but now you have also a limit of 1,000 collections, 1,000 scopes, and 10,000 indexes all per cluster. So you can mix and match those, but these are the working limits right now. They will expand over time, I'm sure, but to set expectations with the customer of how many scopes can I have, it's 1,000. How many collections can I have? That's 1,000 also in your cluster. So overall, we see improved service and efficiency, performance efficiency, security is tighter, and improves the programmability of your application. We continue to support your goals of 100% uptime, and we continue to support your goals of programmability, right? Can a developer control the application themselves, and as well as the operation of the database, and not have to suffer downtime as they're using the application? So you can see integrations with data streaming, data processing like Kafka, Spark, Elastic, and CData still exist. And the move into cloud native technologies and cloud best practices can in microservices development are improved here as well. Jose's got a question of, can I comment a bit on the Python machine learning capabilities? I know that we've added some Python modeling processes inside the analytics service. It's sort of our first step into machine learning kinds of application logic. But Matt, have you got any commentary on that? Do you know anything more about it than myself?
I don't, sorry.
Okay.
And there is also another comment as last question about analytics. So Juan says that we have the analytics, and because of the analytics allows you to do analysis of the operational data, there is no need for an ETL. Can you elaborate a little bit more on that area as well?
Well, we characterized analytics when we brought it to market originally as this no ETL function, because it lives within the Couchbase ecosystem. So data replication is what Couchbase, the analytics service, uses to build out that analytic cluster that you might be processing high volumes of data without impacting the regular operation of the database. You create dedicated services for analytics to process the data, and it does so, and then will deliver whatever its results back are to the application. Now, what's gotten better about Couchbase Analytics over time is the no ETL premise was that all the data lived in Couchbase, but that oftentimes is not true. Right, the customer's analytic data lives in their data warehouses and lives in their other applications that they might be operating. But what we added to the analytics service back in August was the ability to grab data, raw data sets from Amazon S3, from from an S3 bucket, and incorporate that into the analytic processing also. And we've done the same thing now for Microsoft's equivalent to S3 is their data storage, or their raw data file system. If you have data in that Azure structure, you can pull that into analytics service as well. That's new in Couchbase 7. But the no ETL premise was that if the data lives in Couchbase, you don't have to move it to a separate system like Snowflake. You can just process it inside of Couchbase. But now we're starting to also be able to grab data from other systems and move that into Couchbase as well.
That's great. Yep.
So last little bit here before I get to Matt's demo is I do want to talk about two things. One is the backup service. So this is a brand new service that runs just like indexing or query or any of these other services. It can be, it supports multidimensional scaling, so you can tell it to run on those nodes over there, and it will be backing up your database as necessary, writing it to either a file system like Samba or S3, and you can schedule how frequently it runs or how much data it ends up taking to back up. And then you can also point it to where it should restore if you need to restore a backup. So you can restore to a full bucket, you could restore to a scope, or you could restore to a named collection directly. So it gives you a lot more flexibility in terms of and confidence that the service is always going to be running there for you, as well as being able to recover data much more easily than previously. So I think this will become a very popular feature certainly for existing customers. And then global secondary indexes, as I mentioned, become much faster because they deal with smaller sets of data, because indexes are now attached to collections rather than the full size of the bucket. And so this makes the index operation that much easier to be run. Now it'll also be hierarchical and knows if it's at the collection, it also knows what its parent scope is and what its parent bucket is. So that information is not lost. But you'll see a nice performance improvement here when for both indexes that need to get read as well as created. And here's some of those examples, right? Failover is now 4 times faster than it used to be. So it went from 26 seconds to about 6 seconds. Then the Couchbase 6.1. Data rebalancing is, goes from hours to minutes. One of our tests where we were seeing how many buckets we could use, we could rebalance 50 buckets from 3 hours down to about 7 or 8 minutes. So a much faster set of exercises here. And index builds are incredible, right? Because they build in parallel, the amount of time that it takes to build indexes is simply the largest index. Whether it's 100 or 1,000 indexes, right? It takes generally the same amount of time. So a really nice feature there that customers will appreciate. And then when we compare our transactionality support with nickel transactions, we recognize it scales linearly as you scale your environment. So that's our advantage continues to build as the application gets larger and the cluster size gets larger, is when you'll see Couchbase transaction support start to beat out Mongo. Now, of course, Mongo, because their query operations are imperative, right? You can be very specific about what Mongo does in a transaction. It performs very well on a single server, on a single node. So, but that's true of a lot of Mongo operations. A single node system performs very well, but then as soon as they start to scale and add cluster nodes is where their performance really suffers. And a lot of features of MongoDB have a very difficult time scaling out, right? Scaling to multiple nodes or scaling across one database shard to another shard. Those are areas where we can regularly pick on Mongo and say that they really have not resolved a lot of those multi-node and distributed sharded architectures kinds of scaling issues. And then scopes and collections works throughout all of the SDKs. So all of our SDK capabilities are now familiar with that new structure of the database underneath. So very quickly, customer facing, the debate is over. You get everything that you like about relational systems. You get everything we like about from flexibility and performance of NoSQL systems in a single database inside of Couchbase. So we can expand into much more transactional applications much easier, as well as carry forward older applications into this architecture much more easily. And that's the SQL to NoSQL part of the storyline. I will share these slides with you guys as well. And then
Jeff,
Yep.
sorry,
Yep.
when you were talking about MongoDB, there is another question related to our competitors, but in this case, comparing against CockroachDB and Single Store. If you can just elaborate a little bit how we compete with them.
I'm going to steer the, I think those questions to Matt, because I think you worked on the competitive material for those, didn't you?
Yeah, so I can speak to Cockroach a little bit, just at a high level. I'm not familiar with Single Store, so I can't really talk to that. But Cockroach is, at a high level, I'd say Cockroach is still a relational database. So everything that we can talk about comparing NoSQL to relational still applies, right? So the thing here is that Couchbase is now a unique fusion of relational and non-relational concepts, whereas Cockroach is still tied to the relational model. It's still tied to the Postgres API, in fact. Mm-hmm. So you're still locking yourself into a normalized relational model, and all the joins and all the implications of that. Whereas with Couchbase, you can still have a relational style model, as I'll show in my demo if we have time. But you can also work your way towards the more optimized, denormalized model, where you can get flexibility and improve performance from combining data and aggregating data. So I think the story there is that Cockroach is still just the relational model, and Couchbase has multi-model potential. That's a high level. There's other things, other tactics we can talk about. There's a battle card we can share with you if you haven't already seen that. that goes through all the different points as well.
Yep, and I think this is a fine, this one is my last slide of by persona, right? How do you describe this, with the to developers, architects, or DevOps? These messages you'll become much more familiar with as we move forward. And as I said, I'll share this with you. But I do want to give time for you, Matt, to continue talking and showing what were some of those core migration capabilities. So I will transfer sharing to you.
Sure. So I will try to make this a little quick. I'm not going to go the full demo I usually provide, but let's just start here. And Jeff mentioned a few of these things in his presentation. So what my approach is to thinking about migrating or connecting, extending a relational database to use Couchbase is starting with this kind of translation table. So the first column are terms for relational for SQL Server. The second column are the corresponding terms in Couchbase, and specifically Couchbase 7, and how you would map one to the other. And so the important ones are there in the middle. So we have schema in SQL Server that relates to a scope in Couchbase, and a table in SQL Server is similar to a collection in Couchbase Server. And then within a collection, you have documents, and that's kind of the same thing as a row of data in SQL Server. And there's other things that we could talk about, but they all kind of map neatly to the relational concept. However, it's not just a literal translation. There's other things that you gain in moving to Couchbase. So you gain clustering, high availability. You gain JSON flexibility. And so it's that fusion of it's relational plus more, plus more on top of those things you'd expect from relational. But it's familiar to a relational developer, a relational user, that these concepts make sense because they match my mental model already of relational databases. So I'm going to, if I start here with this translation, then I can start to automate the process, at least to start with. And so what I have on the screen here is SQL Server, and I've got AdventureWorks, which is a well-known Microsoft sample database. It's a bicycle store, I believe is what it is. And so I have all these tables in here, and they belong to schemas. So human resources is a schema that has tables like department, employee, etc. Person is a schema that has address, address type, etc. tables. And I can write SQL queries against them. So that's give me the first 50 people in the person schema, person table. And I can do a join to get their email addresses. The font's maybe a little big. But now I can join to another table to get their email addresses there. And that's SQL Server. Now what I've done is I've written a program, a library called SQL Server to Couchbase. And you can find it on GitHub here. I'll post it in the chat. This is an experiment. This is not a supported product. It's not even necessarily something I'd recommend for production. It's the goal here, I think, is to make it a good proof of concept tool or a learning tool to understand that, hey, Couchbase maps pretty nicely to relational concepts. But I've written this program here, and you can feed in a few configurations and options, but basically we're connecting to SQL Server, we're connecting to Couchbase Server, and then we're going to create the collections, the buckets, the data, the indexes automatically based on what SQL Server has in it. All right, so for each one of these schemas, I'll create a scope. So I'll create a human resources scope. I'll create a person scope. And then inside of those scopes, I'll create a collection to correspond to each table. So I'm not gonna actually run that and make you sit and watch the process, but I've already done that in advance. So here is the corresponding buckets for AdventureWorks. It contains those schemas. These were automatically created. And then within those schemas, you can see all the collections in there as well. So person schema has person collection, person password, person email address, and those all match up to these tables here in SQL Server. And then inside of them, the data is also copied over from rows into JSON format data. The indexes are also automatically created based on the indexes that were present in SQL Server. So if we look at person address, you can see that it has, these 3-4 indexes here, and those get automatically created as well. You may not need all of those in the end, but it creates them automatically. So what I can do then is I can take a very similar query in Nickel and execute it here, and I get the top 50 records from that collection. I can show it in table format here, but it's JSON data. And I can still do a join, just as I did in SQL Server, between the person collection and the email address collection, and get all those email addresses in there. So basically the same thing I was getting in SQL Server, with almost the same syntax. Some minor differences, right? In SQL Server, you say top 50 instead of limit 50, right? But it's basically the same thing. And so a lot of these queries are going to be able to run as is even. I can just copy and paste them from SQL Server and right into Couchbase. But ultimately, and Jeff mentioned this as well, you may not want to leave the data in this format to have it still normalized. So we have person and we have email addresses, 2 separate documents. We may want to combine those and embed the email into person. So I haven't done that yet. I'm working on that process still with this utility, but eventually it would look like this, where you'd have one document with all the email addresses embedded. And so now we don't need the join anymore. We can just do a single lookup of the person document. And this is where we're going from relational normalized to the Couchbase NoSQL denormalized model. And we can do this as we need to, if we need to improve performance, or maybe we don't want to do that right away. Maybe we just take the easy path to start with and work our way up to this denormalized model. So that's all I think I have time to show you today, but there's lots of other stuff in this utility. If you want to check it out, you can go, and it's still very much a work in progress. You can go and make suggestions, ask questions here. I'd love for you to open issues. You don't have to write code to ask a question or to make a suggestion. But you can see other issues that have been in here, people asking questions, people making suggestions. So feel free to do that. We want to make this utility as useful and helpful as possible. But again, this is just kind of a proof of concept. We also have some partners that you can use as well. So one of the tools, and I didn't really have time to prepare to talk about this, but GlueSync is a tool that does very much this. You can sync between Couchbase Server and SQL Server or Oracle automatically. And that is literally no coding required. You can just set up that synchronization and it can go both ways. So that's another tool that you can look at. That's more production ready than the one I'm working on. But it's not quite to Couchbase 7 yet. It's going to get there eventually. So I think that's all I wanted to show. I'm happy to answer questions right now or pass it back to Jeff, whichever you want to do.
Ok, ¿hay alguna pregunta? Adelante.
Yes.
I was asking if they have any questions,
Right.
but well, I meet with them on a weekly basis. If they have any questions, I'll directly them appropriately.
Yes, please do. If you've got additional questions or comments, certainly filter them back up to us as well.
I will. Well, I really appreciate your your presentation and your demo, Matt. Thank you very much, both of you.
It's our pleasure. Good luck out there, and hopefully one day we'll all get together again.
It'll be my pleasure. Thank you, guys.
Thank you.
Thanks,
me-
Juan Carlos.
Let me
Thanks,
tell
Daniel.
them bye. Ok,
Bueno.
muchas gracias, señores. Pues estaremos en comunicación. Roberto, pues yo te puedo llamar y puedo platicar cualquier cosa que necesites. Con mucho gusto, estoy a la orden. Señores, pues muchas gracias por su participación. Buen fin de semana a todos. Estamos en comunicación. Les mando la grabación y les mando también esta presentación que nos va a compartir Jeff. Bueno, hasta luego.